says we're recording. Now, last class it said we were recording, and when I got done, there was no recording. Did anybody look at my recording? Because what I did was I borrowed my recording from last semester, I think, which was an in-class on the board. So I apologize for the last one, but you guys didn't watch it anyway, so it doesn't matter. But anyway, that's what happened. It said we were recording and we weren't recording, so hopefully we'll get a recording for today. All right, so this today is where the class gets hard a little bit, although it's not, it won't, hopefully it won't be too bad. So we're going to be talking about confidence intervals. Confidence intervals, actually, am I sharing? I was not sharing. Oops, I didn't mean to do that. Let me try this one more time, then it will share better. Okay, so chapter 16, we're going to talk about confidence intervals. And we're going to talk about the requirements for a confidence interval around mu, okay, if sigma is known. Now, just to warn you, in another thing, we're going to talk about confidence interval where sigma is not known, and that's going to be a different equation. We're also going to be talking about some other things. So, probably should have talked about this first, so I'm going to talk about it first. So we're going to talk about a point estimate. The point estimate is the value of the statistic that estimates the parameter. So some examples are x bar and p hat, okay? Those are the two that we're going to talk about today. So the idea, so remember the x bar is an estimate of mu. Mu is the population mean, x bar is the sample mean, okay? P hat, and that normally, here, let me pull up my my notes. Formulas for the sheets and quizzes, tests and quizzes. Okay, so just as a reminder here, I just want to make sure you know what we're talking about on the formula sheet. So we're going to get into some confidence interval formulas. Now, we've got on here, we've got about 5 different formulas. We may or may not use them all, but the main one I'm going to be using is this one here, x bar plus or minus z sub alpha over 2 times sigma over the square root of n. This is going to be another one we will definitely learn, but not today. And then p hat equals z sub alpha over 2 times pq over n. So we'll be talking about 2 of those 3 today. The idea here is p hat, I guess that's what I wanted to mention. So this is, make that a little bit bigger. So this is your p hat on the formula. This is your x bar on this formula here. So the p hat has a little hat on top of it, and the x has a little bar over the top of it. So those are hard to write on my notes. So I write them as x dash bar and p dash hat. Okay, so the requirements for a confidence interval around mu if sigma is known. So the data must come from a simple random sample, okay? So we're going to pretty much assume, for the most part, that our data comes from a simple random sample. The data must come from a normal population with n greater than or equal to 30, and sigma is assumed to be known, okay? And so that's going to be the case here. So I'm trying to decide if people, oh, they want me to admit people. We've got late arrivers here. Janie, welcome. So we'll do our first example. Residents are concerned about the speed limit and they want to estimate the population mean of speeds of cars on a highway with a speed limit of 45 miles per hour. They tracked 12 cars and found X bar equal to 59.62. So in this case, X bar is our point estimate. Now let me back up a second. Most confidence intervals are of the form your point estimate, which is going to be either your X bar or your P hat, okay, plus or minus your margin of error. Okay, now looking back here, I'm just going to kind of preview here. These are your confidence interval formulas that we're going to be talking about this semester. Okay, so this is your point estimate X bar, and then plus or minus, this is your margin of error. Okay, this is going to be your point estimate P hat plus or minus your margin of error. And so all the rest, everything that comes after the plus or minus is your margin of error. Okay, so let me ask you something here. 12 cars, is that a large enough sample?
No.
No. Now you can get away if your data comes from a normal population, and you probably still in real life should get at least 30, but you can get away with a small sample size if it is known. Now it doesn't say here that the data, it's known that the data comes from a normal population. So this is really actually too small, but anyway, so the idea here, I just want to point out, X bar, you're trying to use the sample of 12 cars in your case. We're trying to estimate the speed of all cars. And so X bar is our point estimate for mu. Now, so I just want to point that out. Okay, so your confidence interval is usually a range of numbers to show what the true value might be. And so we attach a level of confidence. The common ones are 90, 95, and 99. You'll also notice if I go back here onto my formula sheet here, this is something that we haven't talked about too much, but these are the four most, this table here on the right side, these are the four most common confidence intervals that you can have. So if you have a 90% confidence interval, that means, let me back up a second. Let me pull up my paintbrush here. Okay. So the idea here is, if your data come from a confidence interval, okay, and especially if it's normally distributed, and if our sample is large enough, then typically, so this is the population mean. So this is going to be your mu. Now we talked last time, and if I pick a different color here, now the idea here is, so this is, let me back up a second. This is your population. Okay. Now, remember last time we did an example with a bunch of IQ scores in a school, remember? And so the idea here is, with the central limit theorem, you might get, let me try this again. I need to pick a different color. You might get a sample with your X bar that maybe it's a little bit high. X bar, or you might get a sample that maybe it's a little bit low. Maybe this is your X bar. But the idea here is if you do this, say 100 times, when you do this enough times, eventually your X bar is going to match your mean, okay? Now the question is, you don't know which one of these three your sample is if you only do it once, okay? I'm gonna get rid of a couple of these. Okay, so you only sample it once, but the idea here is if you go out far enough, this is kind of a small thing, but that's all right. Here, I'll do it this way. Okay, if you go out here, and if I fill this in, okay. So the idea here is, if this is your X bar, now I didn't draw this very symmetrically, as you can see here, but the idea here is, if this is your margin of error, so you can see that I really didn't draw this symmetrically because the left side is a lot bigger than the right side. That X bar is supposed to be in the middle. But let's say that this is 99% confidence interval. Okay. You can see that mu is in my confidence interval. And so you guys are probably all hopefully familiar, because we did this on the last test. Okay. If I draw another bell curve here. Oh, that was a terrible looking bell curve, but whatever, it'll do for what I'm trying to do. You guys remember the 68, 95, 99 rule, right? Easton, do you remember the 68, 95, 99 rule?
Yes.
Can you tell me what that is?
So if you go one standard deviation away from the mean in either like in both directions, 65% of all of the data should be in there.
You said 65.
Or 68, sorry.
Yeah, there we go. Yeah, so if we go one standard deviation, 68%.
2 standard deviations in both directions, it's 95?
That's correct.
Yep.
So this, here, I'll do this here. So that's 95%. And then 3 standard deviations would be, maybe I'll pick a different color this time.
Could be 99.8.
Yeah, 99.7. Okay. So now one of the things that I just want to point out here really quickly is, so 95 is your most common confidence interval. It's the one that statisticians use most. Now they can use other ones, and in fact, have I shown you guys my favorite statistics website? Does that sound familiar to anybody?
Yes, the what is it? The 3 numbers. I can't remember what the 3 numbers are.
538.com.
538.
Okay. Now, one of the things that they like to do. Oh, now this is interesting. I haven't thought about this. Now they usually do a lot of politics, but apparently they're doing something on the coronavirus, COVID. Oh, there we go. 95% of models change outcomes. Okay, so they've got. Oh, that's interesting. So they've got 3 different models. In fact, this is kind of animated. You can see, but they've got confidence intervals from the different universities that are trying to predict the number of deaths. The one thing that I wanted to point out was when I know in 2018, let's see if we can do this. 2018, model for house seats. Let's see if I get lucky on this search here. Oh, here we go. Oh, now this is really cool. So in 2018, when they had the last election, they were trying to figure out how many seats that the Democrats would win in the race. And one of the things that I was really surprised, so this is really good, but it said that they were going to gain, the median was going to gain 39 House seats. And one of the things that they did, this is one of the few cases where they used, so they did a confidence interval and they said, okay, so we think that they're going to gain probably about 39 seats, but there's an 80% chance that Democrats would gain between 21 and 59 seats. I can't remember how many seats they won, but it was more than 39. How many? I wonder if I can ask this question to Google. How many seats did Democrats win in 2018? And so the actual number was 41. Oh, there it is. Okay, so that was a pretty good guess. So they were guessing about 39, they got 41. So that worked out pretty well. But there's always going to be some uncertainty, especially before the election. I was lucky that they still kept this up. So this was from November 6, 2018. So that was the morning of the election. That was the last time they updated that. But it does show you that that you can use different numbers. So this is one of the few times where I've seen something that was not 90, 95, or 99. Okay. So on our chart, where did I put my chart? Oh, does it not open? There it is. So we've got 4 on here, 90, 95, 98, and 99. So these are your critical values that we're going to go out. So one way to think about it, and this is why I brought up the 68, 95, 99 rule. So if we go out 2 standard deviations from the mean, so this is 2, right? Now, the math actually says it's not 2, it's 1.96, but that's really close. So that's very close to 2. But I just wanted to emphasize, if you go out 2 standard deviations, that's what gives you your margin of error, okay? And so looking back at this formula here, back up just one more time. I'm going to draw one more of these bell curves. Okay. So the most common confidence interval that you're going to have is you're going to see a 95% confidence interval. Okay. And so when we go out here, the idea here is you're going to go out 95% of the time. You're going to go out about 2 standard deviations. It's actually 1.96 in the negative direction, and you're going to go 1.96 in the positive direction. And so what I always tell my students, because occasionally I forget, so if you're doing a quiz or a test, and I say, I want you to do a confidence interval, and I forget to tell you what the confidence is, then it's going to be 95%. Now, and I know I didn't draw this symmetrically, but pretend that's symmetrically. How much is in the tails if I've got 95% in the middle? Okay.
5%.
5%. Okay, so we're going to refer to the 2 white parts here as our alpha. So our alpha is going to be 5%, okay? So the way I've drawn it here, how much, so alpha, so think of your alpha, it's your level of significance. You can also think of it as the probability you are wrong, okay? And so how much do I have on the left side? How much of my alpha do I have on the left side?
2.5%.
You got 2.5% here. And so you can think of this as alpha divided by 2. And then you've also got 2.5% over here. And so this is also your alpha divided by 2. So one of the things I know when you're first looking at a significance thing, so the idea here is we're going to take half of our alpha, so that's why it has z sub alpha over 2 in both of these formulas, okay? Half of your alpha is going to be on the left, half of your alpha is going to be on the right, okay? So, so in this case, 95% confidence interval, that means you're going to be right 95% of the time. You're going to be wrong 5% of the time. Now, I know last time I showed you a, let's see here. I showed you, somebody send me a note. I don't see anything. Anyway, I showed you the projections for the election. Do I still have that up here? Election 2016. Okay. Now, this was the spreadsheet I showed you guys the other day. So 538.com, they were predicting that Clinton was going to win 302.2 electoral votes. Trump was going to win 235, and Evan McMullin was going to win 0.8, so about 1 vote there. Okay, I believe that this here is NBC's projection, if I remember right. It doesn't say on there. So NBC had Clinton with 268, Trump with 204, and then there were 66 battleground states that could have gone either way. Now, so as we're looking at this, think of every state here. So Florida, Michigan. So I got these all sorted. Now, there were 4 states that they got wrong. Okay. So think of these 50 states as 50 different random samples. Okay. So, oh, and I guess, so there's actually, so Alabama, we've also got Washington, D.C. Oh, okay. So this is a little bit different. Okay, so the second, Nebraska's 2nd congressional district, that one was a different poll. And then you also have Washington, D.C. as another one. So in reality, we've got, and we've also got the main congressional district. So if we add these up, there's going to be a little bit more than 50 states here. How many states are there? We've got 53 states or / congressional districts, okay? So if we were doing a 95% confidence interval, how many states would you expect them to be correct on, and how many would you expect them to be wrong on if this was 95%?
Expect 95% to be correct.
95% of the 53 states, which would be about 50 states. Okay, and then you would expect that 5% of your 53 states would be wrong. Oh, I forgot to put those in there. So you would expect about 2.65 of them to be wrong, okay? So they were correct on almost all of them. They only missed on these 4 states, Okay. So that's about what you would have expected. So we would, in fact, that rounds to 3. So you would have expected them to be wrong on about 3. They were wrong on 4. Okay. And in fact, when you look at the forecast versus what actually happened, okay, 48 versus 47, you would say they got Hillary right. And you would say that 47 and 49, you would say they got Donald Trump right. That's within your margin of error. If we assume that this is a 3% margin of error, they were actually correct. The problem was that 3% made all the difference, because instead of being Hillary's win in Florida, it turned into Donald Trump's win in Florida. And so, because the way the Electoral College votes, instead of Hillary getting those 29 votes, because it's winner take all typically, except for in Nebraska and Maine, then we're going to say they got that wrong. But from a statistical point of view, they didn't get it wrong. But yeah, they did pick the wrong winner, but once again, this was very close. But all of these were within the margin of error. And so this is a perfect real life example of when you do the prediction, you would expect to be right 95% of the time, and they were right almost 95% of the time. But they got 4 states wrong, and those 4 states, Florida, Michigan, North Carolina, and Pennsylvania, flipped the election from Clinton to Trump. So does that make sense? One other thing that we could do, I'd probably have to do it again here. This would be a really interesting thing, so I'm just going to do it again. You remember last time when we did the simulation of the IQ scores? I'm going to do that again. Ran between 75 and 125. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to go down 100 rows. Okay, so we've got a school of 900 students. Okay. Now, I'm going to insert a row here. So we can see that the population mean in this case is going to be hopefully close to 100, 99.62, and my population standard deviation, hopefully this is going to be close to 15. Standard deviation population. Uh, 14 is a little bit lower than I wanted it to be. That's okay. Now, if we did a sample mean of all of these, each row, okay, so think of this as a random sample of 9 students. So you can see that one was pretty high. Okay, so I've got a bunch of different sample means here, okay? So 110, 98, 103, 101, etc. So you can see that there's some variation going on with this now, okay? So the idea here is I want to create a lower limit and an upper limit, okay? Now, the question I have for you before I calculate this, is this quantitative or categorical data?
Quantitative.
Thank you, Wes. It's quantitative, right? Quantitative data. Okay, so so which formula here? And I'm going to give you a choice between this one here and this one here. Which formula do you think I should use out of those two formulas?
X bar.
The X bar, right? So this is the formula I'm going to use. So I'm going to copy this. I'm going to paste it over that. I thought I was going to copy that. Let's try that again. Paste, I say. There we go. Okay, so we're going to use this formula here. Okay. Okay, so that's the formula we're going to use. Now, let's just assume that this is my first thing. So what value is this mean? What would we call that value, 110.222?
We call that X bar.
That would be your X bar, okay? Now we need to figure out what is my Z sub alpha over 2. And do you guys know how to figure out how to find your Z score, you could refer to that as your critical value. Wes is shaking his head. Okay, so that's going to be here. Now remember, we've got our formula here. Okay, confidence level, critical values. Okay, we're going to do a 95% confidence interval. Okay, so that's going to be 1.96. Okay, so your Z sub alpha over 2 is going to be 1.96. Your sigma, what's your sigma going to be in this case?
Would this be the 14.38209?
Right, 14.38209. And your N, what's your N in this case?
10.
I think it was only 9. 1, 2, 3, how many do we get there? Yeah, it's actually 9. Okay. All right, so we've got all the information we need here for a lower and an upper confidence level. Okay, so what I'm going to do is I'm going to use this formula here. Okay, so equals X bar, which is going to be your 110, minus your Z sub alpha, which is going to be 1.96, times your sigma, which is right here, your population standard deviation, divided by the square root of N, which is going to be 9. Okay. So I've just done the X bar minus Z sub alpha over 2 times sigma over the square root of N, which is 100. Okay. Now I'm going to do the exact same formula here, but instead of putting a minus sign in there, I'm going to put a plus sign. So your X bar plus all of this stuff. So remember here, this everything that starts with the Z, that's your margin of error. Okay. Now, so this is a little bit surprising because we know that our population mean in this case is 99.62. So is the population mean in this interval?
Yeah.
It's not. Okay, so this is a big surprise. But what I'm going to tell you is if I copy this formula down 100 times, I'm going to expect, how about this one, is 99.62 in that interval?
Yes.
Yes. So here's what I'm going to be doing. If and this is less than that, and this is greater than that, do nothing, else do no. Okay. Hopefully I did that right. Okay. Perfect. Okay. So I don't want to go measure these all one at a time, but we just did a 95% confidence interval. So we've got 100 confidence intervals here. How many of those would you expect to be wrong?
5.
You would expect 5 wrong ones. Now it's funny that the first one we did was wrong, but you can see here, okay, that's the second one that's wrong, 78 to 97. Oh, we only got 2 wrong, but the first one we got was wrong. So that's kind of funny. So we actually did better than we would expected. Usually when I do this, I get about 96 or 94 or 95. So this one actually, you could say, even though we did a 95% confidence interval, we were right 98% of the time. Because there's only 2 of those that are wrong. One of them was too low, and one of them was too high. Okay? So the problem is, when you only do one, you don't know if yours is right or wrong. You're confident that you're going to be right 95% of the time. Which, if I told you you were going to be right 95% of the time on my test, you would be very happy with that grade, wouldn't you? Okay. All righty then.
So we're doing that for the next test, right?
So yeah, so we're going to be doing not just this confidence interval, but yeah, so we've got these 2 confidence intervals here. Okay. So we'll do some other examples here. Okay. So all right, let me go back to my notes here. So a 95% confidence interval where your alpha is 0.05 implies that if you do 100 different confidence intervals, you expect 95 to include the parameter, which means that 5 won't. So, oh, I did write that down there. Confidence intervals, that plus or minus your margin of error. So let's talk a little bit about your margin of error. It's a measure of how accurate your point estimate is, and it depends on 3 factors. Okay. It depends on your level of confidence. Okay. As your level of confidence increases, your margin of error increases. Now, one way to think about that. Let's pretend that we'll do a poll. Okay. Let's say that we've got a 95% confidence interval. And we want to compare that to a 99% confidence interval. Okay, so assuming everything stays the same, what happens to the margin of error when you go from 95% confidence to 99% confidence? Does your margin of error get bigger or smaller?
Get bigger.
Okay. This is okay. We're going to do another poll. Although Wes already gave away his answer. Bigger, smaller. Okay. Let's have you guys vote on this. We've only had 2 people voting. Well, Allie's 3. Okay. Wes and Easton. Not allowing you to vote. It's probably not allowing you to vote because you didn't log in. That would be my guess. Did you log in? I know Janie didn't because it says she's a guest. So Seth. Okay, that's probably why. Okay, so it looks unanimous. We've only got 5 people here today. Where is everybody? Okay. Now, sometimes people, so that's correct. It's going to get bigger. Okay. Now, sometimes people don't understand that, but let me think of it this, let me mention it to you this way. Okay. If we're talking about a pole, in fact, we'll say, here, I'm gonna pull out some numbers. Let's say that I had a confidence. So if I had a 50% confidence interval, if we compare that to a 95% confidence interval, you would assume that your margin of error is smaller, right? So one way to think about this is, okay, let's say that I'm 50% confident that Hillary Clinton's going to get between 45 and 50% of the vote. But I'm going to be 100% confident that she will get somewhere between 0 to 100% of the vote. Okay. What I've done, if I want to be super confident, just make your margin of error really big, and then you won't be wrong. Because prove me wrong that Hillary will not get between 0 and 100%. Okay. So that's one way to think about it. So as you increase your confidence, just increase your margin of error, and then you'll never be wrong. Okay. All right. So anyway, as we talk about margin of error, okay. In fact, as we look at this, it says there's 3 factors. When you look back at your formula, okay, remember I told you that you've got 3 things here. So you've got your significance level here, level of confidence. You've got your standard deviation, and you've got your sample size, okay? So your sample size, as the sample size increases, your margin of error decreases. So when your n gets bigger, it's going to make this whole fraction get smaller, right? And so if you can increase your margin, your sample size, your margin of error will increase. And then the third thing that it depends on is the standard deviation of population. The more spread there is in your population, the wider your interval will be for your confidence interval. So the standard error equals your standard deviation divided by your population mean, okay? So the standard deviation of your X bar is basically sigma over the square root of n. We went over that last time in class. That's basically the central limit theorem. That's why we divide it by the square root of n. So all right, so sometimes they write out the so your mu is going to be between your lower bound x minus z sub alpha over 2 times sigma over the square root of n, and your upper bound x bar plus z sub alpha times sigma over the square root of n. All right, so the critical values, these are your most common ones that you're going to use, 90, 95, 99. I've kind of talked about that. Okay, so let's do an example here from class. Okay, at the beginning of class, we said we obtained a point estimate of 59.62 miles per hour for 12 cars. Since we're using such a small sample size, we're going to have to assume that our data are normal, which is not always a good assumption. But if I want you to find a 90% confidence interval, assume the standard deviation is known. You talk to the police and they tell you that the standard deviation is typically 8 miles per hour on that road. So can one of you help me plug it into these formulas here? So let's pick on Janie. Can you do that? If I've got the formulas right there for you.
Yeah. So would it be 59.62 minus 1.645 over 2?
Oh, now when you're looking at this table,
Yeah.
they've already divided it by 2 for you, so you don't need to divide anything
Just
by 2.
kidding. Okay.
Okay, so it's just 1.645.
Okay,
Okay.
and then times 8 over the square root of 12.
Perfect. Okay. So since Janie did that, Seth, so this is the lower bound, right?
Yeah.
Seth, can you do the upper bound? Are you here, Seth? We can't hear you if you're speaking. Did Janie just leave after she did that? That's weird.
No, I was able to sign in as normal.
Oh, that's why it says you left the conversation.
Yeah.
Because I was like, wow, she got out of there. Seth,
Yes.
can you give us the upper bound? How do we figure out the upper bound?
Sorry, I left for a minute. I went to the restroom, so I wasn't here.
Okay, so Allie, can you do it?
So for the upper bound, that would be the 99%, right?
No, we're still sticking with 90.
Oh, so then you would just do the same formula, but adding it. So it'd be 59.62 plus 1.645 times the 8 divided by the square root of 12.
Okay, now, well done. Now, typically when we're doing a confidence interval, you usually put it in parentheses, and you always put the lower number first and then the upper number first. Okay, so I am going to put this into Excel here and give an answer here for us. Okay, so that's your lower and your upper. And I'm going to change that minus to a plus. Okay, so the idea here is, so if I were writing this on my paper, I would probably write this as 55.82, comma 63.42. Okay. So now the other thing that I want to mention, so here I'm going to copy that before I forget. Okay, so here's your confidence interval. Now, we need to come up with a confidence statement. So I'm going to give you a generic statement, and then I want you guys to fill this in. So we are, and then I'm going to just put a blank here, blank % confident that whatever you're measuring is between lower and upper. Okay, so this is your generic confidence statement. So now that we've done this, Easton, can you fill in the blanks and the parentheses here based on this example?
So it would be something along the lines of, we are 90% confident that the average speed down this road is between 55.8.
I meant to say the mean speed, not the average speed.
Sorry.
Mean speed on this road or this highway is between
55.82 miles per hour to 64.42 miles per hour.
Okay. Well done. So, assuming the speed limit is 45 miles per hour, is there good evidence? Is there evidence people are speeding?
Yes.
Yes, because why?
We're 90% confident that the mean speed on that road is higher than 45.
Yeah, because the lowest limit is 55.82, right? So we think that they're going at least 10 miles an hour over and potentially almost 20 miles an hour over, right? Now, if we change the speed limit to 55, is there evidence people are speeding?
Yes.
Yes.
Yes. Yes, because once again, we think they're going almost 56 miles an hour, right? If the speed limit was 60, is there evidence people are speeding?
No.
No. No, because 60 is in your limit, right? Okay. All right. Let's see here. Can we do the same thing for, and so basically I did all that, but I've got your answer there. Can we do the same thing for a 99% confidence interval? Now the problem is we can't see the formula anymore. I'm going to copy that formula because that's what you're going to be able to look for on the next thing here. Oh, well, whatever. That's not really where I wanted to put it. But we're going to pick on Seth this time since you're back from the bathroom. Can you tell me how to use this formula for a 99% confidence interval?
Yeah, so you would get. Sorry.
Here, I'm going to erase all this stuff so that you can see. Okay.
So you would get the 59.62, and then for the lower bound, you'd subtract. And then for 90%.
We're doing 99 now.
Oh, we're doing 99. Is that what's the? I don't know the value for that.
Yeah,
2.575.
575, perfect. 2.575.
And then you'd multiply that by what is that? By 12.
Nope. What's sigma?
It's still by 8. And
Yes,
then
sigma's 8 divided by
the square root of 12.
square root of 12. Okay. And I did that below, so hopefully we got that all here. So I've got all this information here. So 53.67 to 65.57. Okay. If we did a 90% confidence interval and I changed my n to 48, so you can see here, let me back up before I answer that question. Okay, so with the 90% confidence interval, you can see we got 55.8 to 63.4. With the 99% confidence interval, you can see the lower bound's smaller, the upper bound is bigger. So we can see, actually, I should ask this question before I do that. Based on part A, what is the margin of error in part A? It must be Wes's turn because we don't have very many people to ask today. Can you tell me how to figure that out?
Yes, it would be 59.62 minus 55.8 would be your, and then plus minus. It would just be your mean value plus or minus your lower and upper limits.
Actually, it's just this piece of the equation right here.
Yeah.
Okay. So if I throw that in my calculator, and oh, by the way, hope you guys get really good. I know I'm using my thing here. So your margin of error is just going to be everything after the X bar, basically. So in this case, it's 3.7, almost 3.8. I'll round that to 3.8. So your margin of error in here is 3.8 miles per hour. Now, you could have done what Wes said, but just with a little bit of a difference here.
When you illustrate that, do you need to have the plus minus?
No, because you're adding them, so you usually just do with a plus.
Okay.
Now, Wes said, well, if you take the upper limit minus the lower limit, that's what you said originally, isn't it?
No, that you need to subtract that from the mean. You could do that and divide by 2.
You could divide by 2, yes, that's correct. So that also gives you 3.79. Okay, so that's another way to figure it out. But yeah, basically it's just this part of the formula here, that's your margin of error. Okay, so we can see that the margin of error is 3.8 miles per hour. So you're adding and subtracting 3.8 to both of those numbers to your mean. Okay, now let's talk a little bit about this one here. What's the margin of error for the 99%? What is margin of error in the 99% confidence interval? Let me ask. I think I've talked to everybody now. Easton, it must be your turn again.
So to just find it by itself, you just have the 2.575 times 8 divided by the square root of 12.
Perfect.
And I think it's going to be somewhere around 5.95.
Oh, wow, let's see. Oh, very good, 5.95, okay. So you can see 5.95. So the only thing that's changed is my confidence level. So we went from 90% to 99%, and you can see we went from 3.8 to 5.95, almost 6. So so as your confidence level increases, your margin of error increases. Now, if I go back to a 90% confidence interval, but this time I do my n equals 48, okay? So you can figure out the, wait, yeah, that's right. You can figure out the margin of error here. So before I figure this out, okay, what's going to happen to my margin of error? So I'm going to compare it with the n equals 12 to n equals 48. What's going to happen to it?
Get smaller.
Decrease.
Okay, get smaller. And let's verify that that's the case. Equals that. And it does. It goes from 3.8 to 1.89. Okay, so it went from 3.8 to 1.89. And so the only thing we changed between part A and C was my sample size. Okay. Now, determining sample size. I think I give you guys a question here. This is the sample size that you're going to use, sample size formula, which is that on my formula sheet? I can't remember if it is. I usually don't ask you guys about sample size, but I think there's a few questions on the homework. Maybe I should add that on there just in case. Yeah, it's not on my formula sheet because I usually don't ask you, but apparently there's some questions on the homework. So it's a pretty easy formula. N equals your Z sub alpha over 2 times your sigma over E, which is your margin of error, okay? So I'll have to give you the margin of error in this case. Oh, that's weird. How large must the sample size be required to estimate the speed within 2 miles an hour with 90% confidence? So if you plug that in, so Z sub alpha over 2, you're going to get that off the chart. Here's the same chart right here, okay? So 1.645 for 90% confidence times your 8, which is the 8 miles per hour, divided by, if you only want to have a 2 mile per hour margin of error, that's going to equal 43.29. Now, in this case, we're always going to round up. So even though that's not greater than 0.5, we're still going to round that to 44. Because if you round it down to 43, then you're going to be less than 90% confident. So even if it's 43.1, you'll round that up to 44. Okay. So, so that's the one thing there. Is that all I have? I feel like I should give you guys some more examples. Plus, I want to use the other confidence interval. So, let me see here. Okay, so let's say that, oh, I just saw this yesterday. Did you guys know that there's going to be a vote on here in Utah on June, I want to say 29th or 30th? Did you guys know that? So you guys aren't going to vote? Okay, so here's what we're going to do. The vote, latest Utah poll for the governor's race. I was really surprised to hear this from the Deseret News. Cox moved ahead of Huntsman for the governor's race. Now, one of the problems with this is that we've got more than 2 people here. We've got Cox, we got Huntsman, we got Greg Hughes, and Thomas Wright. So here's what we're going to do. We're going to assume that Cox. So it's either going to be Cox or everybody else to make this work. So June 30th is the GOP primary election. We're going to find out who's going to win. So I want you, so assuming that these values are correct, okay, find a 95% interval for Cox, assuming the DNews poll of 30% is correct, and you interview 578 people. I just made those numbers up. Okay, so first question I have is, which equation do you use? Okay, and I'm going to go back to my formula sheet here.
Is this for anybody?
Yeah.
This would be the one with p hat.
The p hat. We're going to use this one here. Okay. Why are we using that one, Easton?
Because it's a binomial data.
It's binomial data. We're saying Cox versus everybody else. Okay. Now we're breaking the rules a little bit because there's 4 people running, but I can't. We're going to break the rule for this. Okay. We're going to try to keep it easy for you guys.
Out of curiosity, if you like, what would you have to do to reword the sentence to make it like the X bar formula?
We can't do it with. I couldn't reword this. I picked this one specifically because I wanted to use this formula.
That, and even if you had 4, it'd still be categorical, right?
It is categorical, but the math gets a lot harder. So I'm trying to keep it easy. So, yeah, in fact, we will talk about a chi-square distribution, and you cannot do a confidence interval with a chi-square. But anyway, yeah. So, let's go through. In fact, this is probably a good habit to get you guys in. What's p hat? What's z sub alpha over 2? What's your p? What's your q? And what's your n? So those are all the things that we're going to need for this one. So I guess if you know the answers to any of these, and then we'll just plug it into this equation here in a minute. Go ahead and give me that first, and then you'll get the harder ones will be for the people who don't answer first.
So n would be 578.
Okay, so Easton pulled out the easy one right off the bat. N's 578.
P is the 30%.
Okay, so that was a trick question because P is actually not given. P hat is 30%. Now, if P is not given, then you can assume that P equals P hat. So, but technically P is not given. Okay. So you can use P hat as estimate of P if P not given. Okay. Do you see why I said that 30% is P hat rather than P?
Is it because that's like what's like given? I'm kind of confused on that actually.
So P hat comes from the sample. Where does P come from?
The population.
Population. And we don't know, remember the population is usually unknown. We don't know what the population is going to be because we haven't voted yet. The vote will happen on June 30th. And so the idea here is we're using the Deseret News poll. And so we're assuming that the 30% is correct, but we don't know. We have no idea if that's going to be correct or not until June 30th.
Well, if you make that assumption, then your Q, you'd have to assume is 0.7.
Correct. Oops. Does that make sense, Allie?
Yes.
Okay. Now the hard question, what's Z sub alpha over 2?
Is that 1.645?
That was a good guess, but no. And you can't know without looking at the table. So let me find the table for you.
Would it be 1.96?
It would be 1.96. I was trying to find my darn table. So you have a good memory, Easton. It's on this one here.
On another screen.
Yeah, it's 1.96 right there. Okay. All right. So well done. Okay. So who wants to figure out your lower and your upper bounds?
So your lower bound, that would be 0.3 minus 1.96 times the square root of 0.3 times 0.7 divided by 578.
Okay, well done. And I'm going to copy that. I'm going to change that minus to a plus. Okay. So, well done, Easton. Who wants to give me a confidence statement besides Easton?
I'll try it. So we are 95% confident that the news poll is correct with a lower bound of 26.24% and an upper bound of 33.74%.
See, we're not confident the Deseret News poll is correct. We're confident that Cox will get between, and then what you said, 26.2%. I'm going to leave this as decimals, 0.2626 and 0.3374% of the vote. Okay. So well done. Now, another question. What is the margin of error?
%?
Nope. That's too high.
3.74.
How'd you get that?
I did 30% minus the 26.26%.
Okay, so you took your point estimate minus, whoops, your point estimate minus the lower bound. And you got, yeah, 3.736. Okay. So that's one way to do it. Or you could have just taken everything after your z-score. So basically everything here, that would give you the same value. Okay. Does that make sense? All right, can I give you another one? Now, we talked a little bit earlier. What is the critical value for a 80% confidence interval? Now remember, that's not on my chart. 80% is not on there. Okay, so this one's a little bit harder. So how do you figure it out when it's not on the chart?
Go back to the equation.
Google.
Okay. Google. Can't Google on the test though, or the test will catch you for cheating. Let's go back here and let's kind of explain this. Okay, let me open up a new page. You know what, guys? Can I take a quick pause? I've really got to go to the bathroom or I'm going to burst. So while I do that, you can stare at this for a second and see if you can come up with a way to find a confidence interval, and I will be right back. Just one second. All right. Can you guys hear me?
Yep.
Okay, it looks like Easton must have us muted because he's talking, and I was like, I see your lips moving, but I can't hear you.
Oh, sorry. I was talking to a roommate.
Oh, that's fine. Yeah, you're not in the library today. What happened?
I didn't want to drive.
All right. So does anybody have any ideas on how to figure this out? How would you do an 80% confidence interval?
I think I do by looking at the relationship of these things. I
Okay.
think it's the square of the z-score. So
This,
um,
oh, no.
no. Well, if you go to 10%, which would be 1.28, and squared that would give you the 1.645 on the 90% one. So I just thought the relationship was the same.
Wow, I didn't really.
Yep.
Yeah, no, that's not how you do it. Good guess though. All right, so let's go back here. Let's talk a little bit about it. What we want is we want an 80% confidence interval. Okay. So if I draw my bell curve here, okay. So the idea here is I want 80% in the middle. Okay. And we'll fill that in with green. Let's pick green. So I want 80% in the middle. Okay. If I want 80% in the middle, how much do I want in the tails?
10% on each side.
I want 10% here, and I want 10% here. Okay. So what's my alpha in this case?
10%.
Your alpha is 20%. Your alpha over 2 is 10%, right? You want 10% in each tail. So you want half of your alpha in the left tail, you want half of your alpha in the right tail. Okay, so that's 10%. So that's your critical, or I won't say critical value. That's important information, okay? So the idea here is because I don't have 80% on my chart here, okay? Now I have to use this big chart over here, and I have to find 10%, okay? So this is 1, 2, 3, 4, 5. Where's 10% here? So look, that number right there, that is 10%. Okay, so what value does that correspond to? That's negative 1.2, and then I go up there to 8. So, let's see here. So the idea here is your critical value, Z, in this case, your Z sub alpha divided by 2 is going to be 1.28, plus or minus. Now I actually found the negative value. Remember, that was a negative 1.28. Negative 1.2, and then 8. But the nice thing is the normal distribution is symmetric. Now, one of these days, we're going to come up with a non-symmetric distribution, and you won't like it, but so be glad. So the idea here is, if we're drawing this back here, okay, if I draw this value here, this is my mean with the standard normal distribution has a mean of 0, and we're going to go out negative 1.28 standard deviations on the left, and we're going to go out positive 1.28 standard deviations on the right. That will give us 80% in the middle, 10% in each tail. Okay? So just for fun, to make sure you guys know what you're doing, okay? Do you guys have this printed out somewhere so you can access it quickly?
Yes.
Okay. So I want you to find what is the critical value for a 75% confidence interval. Okay. So I'll give you a minute to think about that. So let me know when you've got the answer figured out.
I've got it.
Okay.
I think I've got it.
Okay, so here we'll let Wes go first. What did you get?
1.5.
1.5. What did you get, Easton?
Oh, that can't be right.
Yeah, that doesn't seem right to me either.
I got 1.15.
1.15. That sounds more right.
I wasn't reading my chart correctly. That's
Okay.
what I got to.
What did you get, Janie?
I haven't gotten my answer yet.
How about you, Allie?
I'm still kind of confused on what exactly we're looking for here.
Okay. How about you, Seth?
Same as Easton.
Same as Easton, you got 1.15? So explain to Allie and Janie how you got 1.15.
Okay, so we go to, so for 75% confidence, we go on the chart and we go and get our 75 from, that's our margin of error.
So so I'm going to use the same chart I got before. So instead of 80, we're going to use 75%. So how much do I want in my tails if I've got 75% in the green?
It'd be 25%, but it'd be split into both tails.
So your alpha is going to be 0.25, and you're going to split it into both tails. So your alpha over 2 is 12.5%, right? 0.125?
Yeah.
Does that make sense, Janie?
Yeah, that's where I got when you asked me like what my answer was.
Okay. So you got the 12.5%. Okay. How about you, Allie? Does that make sense? Allie, are you on mute?
Oh, I'm sorry, my roommate was asking me a question. Can you repeat that?
So do you understand where we got the 12.5% for alpha over 2?
Yes, I do.
Okay. All right. So now what do we do with that, Seth? What do we do with the 12.5%?
We'd find it. Where's it at?
We find it on the chart, right? So we're kind of using the chart backwards from how we normally do.
Yeah, and then
So
you find it, the 1.1, and then you go up, and it's the 5.05.
Yes, so negative 1.15. Okay. So, yeah, so that's exactly right. Okay. So, yeah, so it's plus or minus, I guess we could put plus or minus 1.15. Plus or minus, but yes. Normally we don't worry about that. But yeah, we actually found the negative 1.15, and we're going to do the positive 1.15 as well. Okay. So are you good, Janie?
Yep, that makes sense.
Okay. How confident are you that you can do confidence intervals?
I would probably give it like a 75% because I'll probably do something where I'm like thinking too hard about it.
All right. How about you, Allie? How confident are you in confidence intervals?
I'd say I'm at like an 85.
85. All right. Okay. Well, hopefully we get to 95% confidence for everybody. Okay. All right. Is there anything else that we need to talk about? I think I've exhausted all my notes. We can do one more, or I can let you guys go. What do you guys want to do? I heard an but I didn't hear what the rest of the answer was.
Oh, I said I'm good. I don't know about
You're good.
everyone else.
I'm good for either.
Let's do another one.
Do another one. All right. How about you, West? What do you want to do?
Well, I was good until Easton said something. Not. Now I'm not.
You're ready to go? All right. The problem is coming up with good ideas here. Okay, let's do this. You want to check and see if 5-pound bags of potatoes really have 5 pounds in them. You select 35 bags. And get a mean of, what do you guys want your mean to be? Since I'm making this up, you can make it whatever you want it to be.
4.86 because you know they're never going to fill it all the way.
4.86 pounds. You know, this is actually what I actually have people do, and they usually get more than 5. Okay, now we got to come up with a standard deviation. The National Potato Growers Association says the standard deviation is 0.6 pounds. Find we could go crazy and do like a 92% confidence interval or something. Do you want to do that?
Sure.
Nobody ever does that. Here, we'll do find an 85% confidence interval. Okay, and then is there evidence that the company is cheating customers? Answer both of those questions. Okay. So how do we do this? I'm going to let you guys drive everything.
We need to find a lower and upper bound.
Okay, how do we do that?
So you're going to take, so X bar is going to be equal to 4.86 pounds.
Why did you say that? Why is it not mu or p?
So it's not p hat because this is a continuum, not yes or no, but not binomial data.
Okay, it's quantitative data. Okay.
And then we need to find the z times alpha divided by 2.
Z sub alpha over 2. This one's not on the chart, right?
Mm-hmm.
We're doing an 85% confidence interval. So what's your alpha in this case?
15.
Alpha's 0.15. So what's your alpha over 2?
0.075.
0.075. Okay. So we need to find 0.075 on the chart, right? And hopefully this isn't ugly. We're going to find out though. 0.075. Okay. Shout it out when you see it.
1.44.
Yep, we got a negative 1.4. Sorry, I'm on the wrong line. Because that's the number right there. But that's about 7.5%. So 1.44. So very good. So my z sub alpha over 2 is 1.44. Okay. What else?
And then your standard deviation is going to be 0.6.
0.6. Okay.
And n is going to equal to 35.
Perfect. Now that's all you need, but just for fun, just to see how smart you guys are, is there a mu in here?
It should be 4.86, right? Oh no, because that's just of the mu should be 5 pounds.
5 pounds. That's what the label says, right? Okay. So the population should be 5 pounds. The question is, we're trying to find out if this is true. Is the evidence cheating? Is there evidence the company's cheating customers? Because we got a low bag, right? Or it looks like low weight bags. We did 35 of them. Okay. All right. So now what? So we've identified everything there.
Then you plug it into the formula. So for the lower bound, you'd have x bar minus
Okay.
z ace divided by 2.
So we're not using this formula.
I hope not.
Good. We're using this formula. Okay. So I'll put that there just so we can see it. So lower, upper. Okay, go for it, Easton.
So you'd have 4.86 minus 1.44 times 0.6 divided by the square root of 35.
Okay. So it could be, well, actually, so we're going to do the same thing here, except we're going to change that minus to a plus. So, oh, I forgot to do the confidence statement. Whenever you're figuring these out, so Janie, can you give me a confidence statement? Are you confident that you can give me a confidence statement?
No.
Give us a shot anyway.
Oh crap.
Do you remember the template? You're on camera, yay!
I'm gonna just take a wild guess. Oh shoot. If it's between the range, does that mean no? Like they're not cheating?
We'll answer that question in a minute. Well, give me the confidence statement first.
Um,
Do you remember the generic confidence statement?
no.
Where is it? Was it on my notes? Where did I put it?
I think it was on the notes, and then we got rid of it.
Oh, and then I erased it. That's too bad. How did I do that? Okay, so here it is. We are blank % confident that blank is between lower and upper. Okay.
Oh, okay. So is it we are 85% confident that that is it that 5-pound bags of potatoes really have 5 pounds in them?
Potatoes.
Or it is between 4.713957 And 5.
0.71. That's good enough.
Okay, and 5.01
pounds. Okay. Are you more than 85% confident that that statement's correct?
Yeah.
Good. I'm glad you said that. Okay, that was good. That was a very good confidence statement, even though you sounded unconfident. Okay. All right. So now here's the next question. This one's for Allie. Is there evidence the company is cheating its customers?
I would say yes, because the upper is like barely at 5 and a little bit above. So it looks like more than not a big portion of their stuff is under 5 pounds.
Yeah, it's kind of borderline, isn't it?
Mhm.
But I would say no, there is not evidence that they are cheating customers. Because 5 pounds is in my confidence interval. Barely, it's barely in, but because it's in, you can't say they're cheating.
So it doesn't matter if there's like, if most of their stuff is like below 5, like as
Yeah.
long as there's at least one.
Yeah,
And
yeah.
it's in
If it
this.
had been 4.99, would there be evidence now?
Yes.
Yes.
Okay.
But because it's 5.01, there's not evidence. Now, what would happen to your confidence interval if you change it from 85 to 90? Would there be evidence, or would there still not be evidence?
Wouldn't there still be no evidence because your margin of error would get bigger? So
Your margin of error would get bigger, and so it would be more than 5 pounds. Okay. Now, what happens if we went to 80% confidence?
There probably would be evidence.
There probably would be evidence, but there would also be a bigger probability that you were wrong. You could be falsely accusing them of cheating customers and then be like, oh, you just used an 80% confidence interval. So, okay. All right, do you guys feel good interpreting confidence statements?
Yes.
Okay. All right, so quiz is going to be on chapter 16, and that will be due on Friday. Sound good?
Just out of curiosity, with the remaining time that we have left for the semester, what does the structure look like as far as exams going forward?
That's a good question, because usually I like to have, I need to look at my next, what's my next chapter? We're going to do chapter 17 next, and I haven't looked that far ahead. Because I usually like to do a test after chapter 16, but we've only covered 2 sections. We'll probably do, see, this is when the class is going to start to really get hard. We're going to do language of a hypothesis testing tomorrow or Friday. That would probably mean, I don't know. We'll probably have a test. We will definitely have a test next week. The question will be, will it be Wednesday or Friday?
So we'll have one more exam and then the final, or is the final just an exam of the remaining chapters?
We will have a final. So yeah, we'll definitely have a test next week. And then what does the calendar look like? I haven't looked at the calendar for a while.
I think it was like June 24th or something was the final for this.
I haven't looked at my calendar as much as I could. Okay, so today, I haven't even followed this very well. Today's what? Today's the 10th? We only covered chapter 16 today.
Well, isn't this calendar also as if we were meeting 4 days a week?
Well, I said we were covering 2 chapters there, and we only covered 1. That's why. No, this is 3 days a week calendar. So I need to update this. So we had our exam 2 then. 1, 2. So we'll probably have a test, yeah, on the 9th, either the 17th or the 19th. And then we'll have the final on the 26th. So yeah. So the final will be comprehensive though. So yeah, so plan on basically the next 2 weeks, we're going to have a test and a final.
And at the beginning of the semester, you said that our quiz scores would replace, was that one of the exams that it would replace?
Yeah, one of these 3 exams.
Okay, one of the 3. Okay.
Yeah. It will not replace the final though.
Yeah, I was just checking, make sure.
Yeah. Yeah.
Just out of curiosity, and I'm sure that you haven't had this happen very much, but I did really poorly on a couple of the quizzes, but doing better on the exams. What if your quiz score is lower than all 3?
Then we'll just take your exams.
Okay.
So yeah, there are a few people who do that, but not very many. So good for you that you're doing so well on the exams though. Any other questions? Okay, don't start the air hockey table for just a 1 minute, okay, guys, because it gets loud. And I'm almost done with class. Any other questions?
No.
Okay. Well, hopefully we have a good recording today. I'm going to stop the recording. This is good because I see stop recording. So that's a good thing. So I will let you guys go.